So let's talk about incremental backups. What this feature basically is, what benefits it gives to its users, and how it was implemented in PostgreSQL 17. What is basically an incremental backup? We are talking about the case when we created a full copy of our database at some moment of time, and then we want to capture and store only the changes in the dataset. So we save space, storage space, and also decrease the time needed to complete a single backup operation. Benefits which incremental backups give their users include reduced storage requirements, you need less space to store less data, faster backup times, so you don't need so much time to complete just a small portional backup, simplified database operations, which means that when you need to restore or clone your existing database, you can do it faster and with less number of steps, and saving costs for cloud or your on-premises storage. So the less space you need to store some number of backup copies, the less it's gonna cost you in the end. Now let's talk about how incremental backup works in PostgreSQL. The existing tool, PG-based backup, was enhanced with new capabilities to support incremental backups. So now you can add a specific flag, which is I, which stands for incremental. With this option, you can refer to an existing full backup copy. And this will let you to create incremental backups, for example, for different full backup copies if you, for some reason, prefer to have many of them. Now you should use full backup as a baseline, which means that initially, yes, you have to create at least one full backup copy. So it's gonna take time, but only once at the beginning. And then this full backup is going to serve as a starting point for all subsequent incremental backups. And what else was added is a manifest file, the file which describes the changes between the prior full or incremental backup and the current backup event, thus allowing PG-based backup to track which data blocks have changed since that point in time, which is quite important, and we're going to stop on this in a moment. Now let's look at the three basic steps which comprise this incremental backup strategy. So you have a full backup where you use PG-based backup without the I option, without this flag to create your first full backup copy. Then you use the same utility but with a new flag specifying the full backup location with its manifest file to create an incremental backup. And all the subsequent incrementals, all the new incremental backups in future should specify the same manifest file of the most recent previous backup. So every time you basically refer to what we've done the last time. Now let's start from this point in time and just capture all the changes and save them as a new incremental backup copy. Let's move to the practical examples. So here you can see how we create a temporary folder to store our backup files. Then we enable wall summarizer, and I want to go over this part in detail. So a new process was added to PostgreSQL, responsible for finding and tracking those changes in data in order not to write all changes for the same row, because we don't need to store changes for a row which has been changed 10 times since the last backup. We just want to take its final state, right? So to remove all the interim states this record has gone through. So here we enable this process by altering the running instance. Then we create the database just for the sake of example. We create a table there and we fill it with some temporary data, 10,000 records. After that, we create a full backup as our starting point. So we run PG-based backup, we provide the output directory where we are going to store our backup copy, and we list it on the screen just to give you the view of what it looks like. In this folder, as you can see, we have the full copy of our configuration files and data files, along with a new file called backup manifest, which we discussed earlier. So this is a manifest which describes this backup copy and specifies that, for example, this is a full backup. Now we are going to go back to the database and add more data to the table to simulate the changes which usually happen in the real world. So we are going to add another 10,000 records to the same table. Then we are going to create an incremental backup specifying the full backups manifest file with this new flag called I. As you can see, the new directory is very similar to what we've seen in the full backup folder, but it also smaller in size, and its backup manifest is a bit different. And I'm gonna show you that in a couple of minutes. So we are checking the backup label file. Here you can see the label tag. And you see that we are using base backup here in our incremental. So this is a sort of a reference. And we see that this backup is incremental by the last two lines on the screen. So it's incremental from the specific logical sequence number, the position in our transaction log, or talking in terms of PostgreSQL wall. And if we go further, the way how you can restore this incremental backup is just providing it all the backup directories in the proper order. So you start with the full backup directory, which is followed by incremental backup folders in the order of their creation, from the earliest one to the latest one. The last parameter on the screen is a new output directory where you are going to restore the database with configuration files and data files and run the new database cluster from that directory if required. To conclude this section, I'm going to talk about comparison between incremental backups and so-called point-in-time recovery. In the current PostgreSQL version, you can first take a full backup copy and then just write down or archive each wall file with all transaction changes happening since that point. This will let you restore the backup, then replay every change which has happened since taking this backup copy up to a specific point in time which you are interested in, thus recreating the data directory as it was at that point. So you basically say, I want to see my database on this moment in time, and you can achieve it. So usually this technique is called point-in-time recovery. Logically, the result of a point-in-time recovery up to an incremental backup point, so the moment in time when you created an incremental backup copy, should be the same as restoring this incremental backup at that point. So you just go to the same point in time in two different ways, but the destination is the same. The difference, however, is the size of the incremental backups. So if we just sum them up, you will see that often their size is less than the combined archived wall file size, because you simply don't need to store all those interim changes. If this approach meets your requirements and you are fine to have less storage used by your backup copies and faster time of recovery provided by this new strategy, then you can basically go with it. But if for some reason your system requires the ability to be restored to a specific moment in time, no matter if it's the day when you created this incremental backup or 5 seconds later, then you should go for a point-in-time recovery strategy.